Hello and welcome everybody. This video is part of the lecture series of this course, Programming for Engineers, specifically for mechanical and civil engineering students. My name is Dr. Sami Salama Hussein Hajjaj and I'm going to be instructor for this course. In an earlier video, I discussed the contents of this course and I described all of these elements in greater details. Make sure you go and check it out. I'm going to leave a link to that video in the description area. We are now in this part of this course in part 2, Programming C++. I've already covered all of these previous topics and they're all available in other videos, such as the fundamental topics, essential skills, installation and setup, and even working with data, and specifically on variables and collections. And also we have covered in a previous video the contents of operations. So the purpose of this video is to cover exactly conditionals. Actually, yes, and this part or this segment of the syllabus is covered manipulating data. And in a previous video, I talked in details about operators in all of these types. I suggest you go and check it out before you come to this video. So in this video, I'll be focusing specifically on conditionals, the if statement, and the if statement with more operators, logical and comparison operators. Like we said in that previous video, when we actually introduced those operators, we did not do much of examples because those will be provided here when we are in this discuss the if statements. We're also going to discuss the switch statement. And by the way, as part of the if statement, we also have the else statement, or we're going to discuss a little bit more about else and also about the else if. You can say that these are also included within the if statement. I'm going to discuss the differences between if, else, and if, else, and so on. And then also finally, we're going to end with exception, or specifically the try and catch statement. Although in the slide it says intro only, but then in this video, you're also going to see a hands-on example of the try and catch statement, where we use it to actually do validation. So I hope you benefit from this video. Let us begin with the content of this course, specifically on conditionals. Okay, so let's now move on with conditionals. Now, sometimes the meaning of the word conditionals basically depends on the condition. What does that mean? See, sometimes certain parts of the program we would like to execute only based on certain conditions. We don't want to run the program or everything in the program. For example, if the sensor values is greater than the maximum limit, only then open the door. So we don't want the door to be open all the time. We just want the door to be open only if somebody is near the door or something like that. And that is why sometimes we have conditionals along with the logical and comparison operators, right? Essentially, we can then use to achieve this effect. There are also a few constructs that allow us to do this. We have actually several types of conditionals. We have the if statements, it's a family of statements. We have the switch statement, not statements, just one switch statement. And then we also have the exceptions, which is a try and catch. Now, what is the difference then? We obviously, we execute a command if certain condition or conditions are true. And then what about the switch statement? Sometimes we have multiple conditions and cases to select from. And it's usually not just multiple condition, but multiple exclusive condition. And I'm going to come back to this in a minute or in a while when we talk about if statement. But I just want you to add this keyword right here. So although we can use a switch case with, if not exclusive, but sometimes or the highest or the power or the main power of the switch statement is when those conditions are exclusive. Okay, what is an exclusive? Let me ask you right now, what is the day of the week? Today, what is the day of the week? For me today, it's Tuesday. So obviously, if it's Tuesday, then it will never be any other day of the week. So therefore, we can say that the conditions or the options of the day of the week are exclusive. What does that mean? It means if you select one day of the week, then it cannot be any other value. You cannot have 2 days. You cannot say today is Tuesday and Thursday. That's not the work, right? So it's either one of those values or nothing else. If that's the options, if you have several conditions, and only one of them can be true at a time, only one of them can be true at a time, and if that one is true, then the others are automatically false, and we call that scenario exclusive conditions. And if you have that scenario, or if you have that condition where you are dealing with several options and they're exclusive, then the switch case or the switch statement is the most powerful construct for that case, and we will see that in action later. Now, the exception or the try-catch statement or construct is slightly more advanced. We will not do examples, but I'm going to give you an idea what's going on. But then basically, the exception or the try-catch is when you want to try part of your code that could cause problems. Yeah, if you some parts of your code you're not sure what's going to happen, you cannot predict really the outcome. Maybe you involve user and interaction, and you cannot really control what the user can or cannot do. So in that case, you would want to use an exception, or you want to use a try-catch. And in that case, you will then prevent the program from falling apart or from crashing. And once again, we will see those in details in the next few slides. So let's talk about the basic one, the if statement. The basic form of the if statement is simple, really. If you simply have an if and you have a condition right here, and then basically this is the block of code that you want to execute. And then, as you can see, this block of code, we're going to refer to it as the if statement code. As you can see, the if statement code. That code, or this code right here, I put here two lines. Could be a lot more than that. Could be even a lot more complicated than that. But the idea is simple, that this block of code will run only if that condition up there is true. So if this condition is true, then only then this block of code will run. So let's take a look. Let's try and do that. So, okay, so I'm going to come here now and say, you know what? I'm going to come here now and put an if statement right here. So if angle, yeah, I want to actually copy this and put it here. And I'm going to say if angle is greater than or equal to 45. Only then run this code. So I'm going to take all of this code that we did here, right, and then put it inside the block. And this is perfectly fine, but just for clarity and then for organization, I'm going to simply do this to indent a little bit. In C++, there is indentation is optional, just for clarity of the code. By the way, some people, when they write in C++, they prefer to write the brackets like this. I'm not gonna get into that debate. Some people prefer it this way, right? And the idea is that if you do that, you can hide this code, but you can still see the condition. Whereas if some people like me, I prefer it this way. And then if you actually do this, it's the same effect, but just the bracket's still visible. Some people don't like to see the bracket, so just do it this way, and then boom, it's still visible. I don't really know why. It's really a matter of something. It's just a matter of personal preference, really. There are very rare people who put that last bracket down there here, and I don't know why. This makes the code a little bit ugly. Now, nowadays we have in our IDEs, as you can see, the bracket can be tracked. Like if you put the cursor right here, you see the color is already highlighted, telling you where the closing bracket for this one is. So let's say if somewhere else you added an extra bracket, let's just say here, then you will see now that this bracket is going to close here, which is obviously incorrect location. You want the bracket to close here, so that will be an automatic way to help you get there. Now, if you are from my generation, then you will know that this is a blessing. Back in my time, we did not have this color thing, and you will have to keep track of the brackets yourself. So that's why if you simply drop this bracket by mistake, right, and you try to compile, you're obviously going to get an error. And then the problem is that where is that extra bracket? You'll have to start tracing things. So that is why these color-coded bracket colors are really awesome. Anyway, let's get back to the topic. I sort of went offhand here. So now I put a float equal to 45, and then I put a condition is that if it's greater than or equal to 45, only then perform the task. Well, let's see it. Compile success. And what do you think is going to happen? Now, just now, by the way, let's make this as a habit. Before you run the program, try to predict what's going to happen. In your head, try to read the code and then try to say or tell to yourself what is going to happen. This is an excellent mental exercise because that can actually help you sort of learn how to read code, learn how to follow the logic. And read code and follow the logic of the code are two essential skills that any programmer would need to develop. If you are able to predict the behavior of the program before it runs, and then you see it happens the way you predicted, that can be a form of confirmation that you are on the right track, that you can actually read code just fine. So make sure before you run any kind of program, try to predict what's going to happen, the behavior, and hopefully whatever you predicted goes through. If not, then you should simply read the logic again and try to see what happened to your prediction. Why didn't you get it right, or what was the mistake in your prediction? And again, that will help you develop that skill even more. So again, build. I predict since the value is 45 and we put an equal, so it will run. So actually, we were going to see this running. So if that was your prediction, good for you. So let's take a look. And yes, cosine is this and sine is that. We're good to go. Now let's change the value a little bit. So let's just make this to 30. So if the angle is 30, now let's try to predict what's going to happen. According to this condition right here, this is actually greater than or equal to 45, but the angle is 30. So obviously this is not true anymore. This is false. And therefore, if this is false, what's going to happen? Well, if this is false, then everything inside this block is not going to run. It's going to be ignored as if it was a comment, really. So let's try this. Try that. And since we don't have anything else in this program, we should see nothing, right? So run again, nothing. So let's take a look at what's going on here. I wrote a bunch of code here. So what happened? What happened was simple. When you define this value as equal to 30, but the condition says only if it's greater than or equal to 45, then run it. But since the value is less, it's not greater than or equal to 45, then this program did not run at all, or this part of the program or this block of code did not run. And then we came here. And since there is nothing else after that, then you simply see that there is no value. So you know what? Let's just see this. See out. And I'm going to do this. So, okay, so yeah, let's just do that way. Okay, so how about, okay, so what about this condition? When theta is actually less than 45, or less than, yeah, less than 45. Well, that actually brings us to the next slide. So let's get back to our slides. So this is basically how the if statement works. Okay, what about the else? Now the if statement can be extended a little bit. We can actually add what's called the else condition. So we have a condition and then execute if this condition is true, and then we have an else command right here. And this will be blocked if the condition is false. What condition? Exactly the same condition here. So this condition have two outputs, right? If it's true, right? Or is it false, right? And if it's true, then this will run, which is the block of code you see here. But if it's false, then this will run. Make sense? Let's go ahead and try. So go back to our code again, and now we see here. And then I'm going to write this else. What do you mean by else? Well, essentially, and right here. So essentially, this is now the condition. So as you can see here, it's greater than or equal to 45. Is there any other possibility? Yes, it could be less than 5, and that's it. So if you want to be explicit about it, you can actually write another condition here. But you know what, let's not get to that. Just say else. Now, what does that mean, else? Else mean if less than 45. Is that right? If you want to write it in pseudocode, you can just say if less than 45. Is that right? Now, this is a comment right here. This is just for your own clarity, just for you to understand what this else means, right? Okay, so what do you want? Well, if it's less than 45, we want to give a message to the user, tell him, no, excuse me, Mr. User, the value is less than the minimum requirement. Error, the value is less than the allowed minimum. Okay, and that's it. So it's going to print out a message. We don't have any value to print out. We're just going to tell the guy, you know what, this is just, you know what, although I could have done this much, I want to keep it like this just for organization's sake. Okay, so let's compile this. And now remember, that now once again, try to read the code before you run it. So the value of this thing is 30. Okay, we have two conditions here now. The first condition is that if the value is less than, greater than or equal to 45, obviously it's not, so this is false. And because this is false, none of this will run. We're just going to skip all of that. We're going to come to the else. And the else is going to check if the condition is false, or in other words, less than 45. So therefore, this line will run. So when we run this program, we should see error, the value is less than the allowed minimum. Let's take a look. Compile, build, and execute. And here we go. And that's exactly what happened. Okay, let's play with the values again. So right here, let's just put this as 50. And now let's see. Once again, try to predict the logic. So if the value of this was 50, so therefore the angle is, obviously this now will become true, and therefore you should see this right here. Okay, so let's just try this and run, and yes, cosine and cosine, something like that. Okay. Okay, let's play a little bit. So I want to actually do something here. So instead of hard coding the value like that, let's allow the user to play with the value itself. So enter an angle, and that's it. We're going to ask the user to enter an angle, and yeah, leave that here, and then we're going to simply first we're going to initiate the value. This is something we've done in our previous video when we worked with variables, so make sure you go and check it out, because we also worked with user input. So now we are initiating the value, and then after that we're going to take cn, and then we're going to assign it to whatever the user inputted. And then from here on in, it's all the same. So instead of basically asking, instead of hard coding the value ourselves, we will allow the user to input the values themselves. So build, execute. So now the user can now dictate what happens to the program. So I'm going to write 30, and then error, the value is less than the allowed minimum. You know what? You want to be, just say this, enter an angle, minimum 45. Yeah, that's it. So minimum 45. Okay. Okay, so let's just say that the value is minimum 45, so 45 or greater will be allowed. So if I put 30, which is not, which is against the instructions, then you're going to say the minimum is not allowed. So if I actually if I run this again and I execute again, and this time I listen to the instruction and I put 45 or greater, then it's going to perform the operations. Is that clear? So this is how we can actually write a program that the output of the program, it depends on the user input. Okay, so now let's actually, what's next? Yeah. After this, we come back to, now let's take a look at the else condition here and try to see the effect of the else. If I actually come back here now, and let me just comment out this line and this line right here. In other words, I'm just removing the else statement altogether. I'm just writing this F condition is going to check for greater than or equal to 45. And after that, I have this C output value. And once again, try to predict the output of this program before we run it. Think about it for a minute and then see the effect, or try to see the difference. Right now, what we did was we simply removed the else part altogether. And then this is basically a C out on its own. So then we have an if statement, and then we have a C out. Okay? All right, so let's take a look. So now again, there's this condition, which is 45. Okay, let's take a look at the situation now. And let's just begin by by following the instructions. So I'm going to put 50, which is greater than 45. And then let's check out what's going on here. Yes, the program worked because the condition was true, right? So this actually worked. Okay, but then this also worked. All right. So let's allow that to simmer in a little bit. And before we discuss what's going on here, I want to make one more change. I want to run this program one more time. Yeah? So let's close this and then try it again. But this time, let's make it a wrong value. Let's just say something below 45. Okay, and then once again, you will get the error testing is not allowed because it does not work. So what's going on here is that this part of the code, you know what, I want you to pause right now, think about it, and try to explain the logic in your own words. Or try to explain the situation now in your own words. Okay, I hope you did. So now what is going on is actually, right here we have a conditional, right here. And the conditional is that this block of code will run only if this condition is true. Okay, what have happened if this condition is not true? I don't know. We did not actually account for it. This C out is going to always happen regardless of what happens here. You know what? I'm going to remove this all together and then make it. This is how actually it looks like. So the conditional that you're looking at right now is only here. So this right here, this is simply a conditional. I'm going to put it here actually. So basically conditional and check uh, angle check angle value. That's it. So this conditional right here, excuse my spelling, yeah, right here. So this is an N and right here. So basically this conditional right here is going to run, but then this now has nothing to do with this line. This C out is actually outside of this conditional. It's not affected by it. So regardless of what's going on here, this C out will always print out. If this is true, okay, this line will run, no problem. But then this will C out will also run, because after you run this block of code, the compiler will come here and then, oh, and a new command, okay, it's going to run it. Now let's say if this conditional was false, okay, these 3 lines of code will not run, but then after that the compiler will run here and then again another line of code. So this C out will always, I mean, the way that it's written right now, it will always run regardless of what's going on inside the if statement. Now, if you want the C out to operate only when the condition is false, then you can then put it in a way that we did earlier, which is using the else command. So once again, you can come here and say else, and then put another bracket here and close it here. And in this way, the C out will only happen if the condition is false. So this is basically now some of you might be thinking, so what's the big deal? The big deal is that it depends on the behavior that you want. Sometimes you want this behavior that this output only happens if you have if this is false. But sometimes you still want this behavior. Sometimes you don't care about the else condition or the if condition. If you or sometimes you only about the situation if this is true. What about the situation if this is false? You don't care about it. You're simply going to ignore it. And then the program will proceed regardless. You get me? Sometimes you do care about the else condition or the opposite condition. And then in that case, you would want to use the else statement. So this is what I meant by here in the slides as, can you see the difference? Can you tell the effect of the else command? The else command essentially is used to count or account for the opposite of the condition. So once again, if you have a certain condition here, then the else will essentially check the opposite of this if statement. Okay, by the way, some people when they write the else statement, they write it like this, sort of again to emphasize the point that these are all related. That when you check for the if statement and you check for else, you mean else of this if statement. Is that clear? What does that mean, this else? What if we have another if statement above it? Let's say I put another if statement here. So let's just say something else, right? For now, I'm going to write pseudocode here. If another condition, okay? And then if another condition is also true, right? And then over here, you will have a different block of code, right? So you'll have here something else to do, okay? Something else to do. Okay, and you put these like this. Actually, if that's the case, this else right here is not gonna check, is only gonna check this one right here. Is only going to check this last if statement. All right, so let's understand the concept of else. That else by itself simply is going to check this last condition. Meaning, if there is another if statement above it, then this else is not going to account for this if, the previous one. It's only going to check for this if only. Okay, so what if I want this else right here to check for both if statements? Yes, we can do that. And I'll come to that in a minute. And that will actually brings us to the if else statement. So what is the if else statement? Well, we can actually expand the if statement a little bit by simply adding another else here. What does that mean? So if I go back to our program, if I were to put another else here, and now these 3 statements are now all connected. Okay, what is going on? So you can see that, you know what, I'm going to do this right here. So I'm going to actually check if it's greater than 45, then you know what, I'm going to do this. So I'm going to take this, what do you call this thing? I'm going to take this value, this conversion, I'm going to put it here. And then the output will depend on the value. So what I'm going to do right now is, if the value is greater than If it's greater than 45, then find the cosine. I think that's a good idea. And if it's, yeah, if it's greater than 45, then find the cosine. If it's less than 45, then we're gonna make this actually like this, and then else will be the third condition. You see that there. You get what I mean? So that's basically what's going on. So now you have three conditions. Now, if you put them this way, you can have if and then else if. That means you're now checking a specific condition. Okay, if this is the condition, if condition one is true, then condition one is true, and then condition two, you have now a second condition is true, condition two, and then you also have something else. So how does this work now? How does the logic work? Well, now you have three situations, if, else if, and then else. So the way that the logic will go is like as follows. First, you're going to check this first condition. If this is true, then this line will execute, and then all the others will not run because this is already true. Then we come here now. Now, else if simply means if this condition, now if you come to this point, that means if there's an else right here, that means this condition is a false. So when will this line actually operate? If this is true, yes, if this condition is true, I'm gonna put it here, yeah. So the logic right now is this run only if condition one is true. Okay, so this will run only if condition one is true. Okay, what about then here? So because you put an if and else if here, so that means the only way that actually we will consider this second condition if this first condition was not true. So which means then we will have to come here now and can actually do this. So now run only if condition one is false and condition two is true. This will be a little bit confusing to some people, but then I hope with this example, with the example we will run now, it will make sense. So what does that mean? So essentially, we actually made those options to be exclusive. So if the value is greater than 45, it can never be less than 45. So basically, and then the last one will be obviously the third possibility, which is equal to 45. Okay, let's just try and see what's going on here. So yes, yes, sorry, before we get to the run. Okay, so this will run if both if condition one and condition two are false. So this will run if condition one and condition two are false. Okay, run only, by the way. Yeah, run only. So let's do that. So compile, build, and then allow the user. So I'm going to begin with a number that is actually greater than 45. So I'm going to begin with 50. So as you can see, oh, this is still the old version of the code. So let's compile it again, build it again, and then run it again. So 50. Okay, I did not change this. So 45 is greater. This is less than 45, so it should not run. So compile, build. Oh, we have a build error. Okay, so let's try this again. Compile. Why is this permission denied? You know what? I'm gonna close this file. Oh yeah, because the thing is running. Okay, sometimes this actually happens. So I'm gonna open the file again, operators. Okay, this is our program, and compile again, build again, and then run. So now put 50 and yes. So now, you know what? I want to make this output a little bit more informative. So since it's greater, I'm going to say angle is greater than 45, and then cosine 40, and then yeah, and then essentially greater than 45, and then that's it. So I'm going to remove all of that stuff that we have here, and we're going to actually then change this output to make it a little bit more informative. So right here, the angle is uh, less than 45, and in the last one, we will actually have angle is equal to 45. Okay, so that's essentially our compile, build, and run. So now let's put a number that is greater than 50, 45. So that's 50. What did I do here? So greater than 45, angle is greater than 45. We are having the same problem again. Let's try again. So compile, so 50. Okay, I'm gonna do this again. So open again. Sometimes the memory gets stuck a little bit. So let's try this again. So 40, 50. Am I doing something here? So if the angle is greater than 4, oh wait, because, oh yeah, I remember now. Because we have already converted it, so the number is already smaller than 45, my bad. So I'm gonna do the conversion inside now, although this is redundant and multiple line repeated, but let's just ignore that for a minute. And then finally, actually we don't need to do any conversion, yeah, because we're not calculating any sine or cosine. So I'm gonna actually, yeah, I'm gonna ignore the conversion for now. So we're not calculating any sine or cosine. So it's gonna ignore the conversion. And we're gonna work with the what do you call this thing? We're gonna work with the degree values. Okay, so now 50. Yeah, so now 50 is greater than 45. So angle is greater than 45. Okay, now all right. So now what happened was that this condition now is true, and because this condition is true, so the other two conditions did not run. Okay, so now I want to activate this. In order for this to work, this has to be false. So we're going to put a value that is less than 45, which is 35, and then we have to make sure that this is true. So let's try this again. So I'm going to put 30, and then again, it's less than 45, so that will work. And then I'm going to change something here. So I'm going to actually greater than 45, and that's okay. I'll just play with that for a minute, and then of course run this again, and then put 45. Yeah, 45 exactly. Then angle is equal to 45. Okay, what if I simply do this? I remove this else right here. What's going to happen? Let's just try it. And so once again, now you see how the else f works. Okay, what about if I simply remove this else right here? What's going to happen? Now, before we go any further, let's just theoretically try to understand what is the implication. First of all, when you actually put the else here, then you have this whole structure as now as one unit. You are checking first one condition, then you check in the second condition, and you check in else. But if you remove this now, then now this will be independent from the last two statements. So you have one condition on its own. This could be something else completely. And now you have this condition, and then the else will only deal with this guy only. And we've seen that earlier. So let's try this now. So the value is, now of course, in our case, this will still work because the values are exclusive. So this, or maybe we are still testing the same item. So let's actually try something else. So if yeah, let's say that if angle is is greater than 50, but then again smaller than 45. Um, you know what? Let's make this yeah, greater than 45, but then less than 50. Is there a way we can make this true both cases? Less than 45 and greater than 45 could be 48, but 48 is also less than 50. Is that right? So by right, this means that this condition is true and this condition is true if we select something like 48. Okay. You know what? Let's just do that with else f. Okay, else f. So let's see what's going on here. So right now I changed the conditions a little bit. So this is actually greater than 45. This is less than 50. So any number between 45 and 50 will make both conditions to be true. Is that right? Let's see how that works. So I'm going to put 48 and let's check out what's going to happen. So now you see here is f at the angle is greater than 45, which is this one right here. But then this is also true. Angle is also less than 50. Is that right? the value that I entered, which is 48, is also less than 50. So why didn't this line actually execute? And the reason for that is because we put an else here. What does that mean? Means is that if this one became true, then everything else below it will automatically be ignored. You will only select the very first true conditions. It's not going to check again, check the others. So if you want to make sure that every one of these options are exclusive output, then you use the else command. So I hope that this concept is clear here. Okay, so what if I want to check every condition and I don't want it to be exclusive? Well, in this case, you remove the else, remove the F here. And this else was going to check only this condition, but it's gonna ignore this other one right here. So let's just try it now and see now what's gonna be the difference. Now, once again, try to predict the output. So once again, now we have an if statement on its own, and now this another if statement on its own. So these two if statements are completely independent of each other. You get what I mean? If you want to be a little bit more exclusive or more explicit, you can actually come here now and say if this value is equal to 50, something like that. So this way, you will have now 3 independent if statements. They have nothing to do with it. And then, you know what? I'm going to get back to that in a minute. But first, let's just focus on this right here. So now that you have if and another if without an else, that means these two if statements are now independent of each other. So let's just try this. Now check this out, yeah? Before we run, this is true if you put a 48, and this is also true, right? So let's give it a try. And if you have 48 right here, and then now you have 2 outputs, because this is true. Where did that thing go? Yeah, this is true, and then the other line is also true, because these are 2 if statements that are independent of each other. Now check this out. I want to make another exclusive or another independent if statement. I'm going to say if I'm going to actually copy this whole thing right here. I'm just going to copy this whole thing and put it here. So now I'm going to say if, and this is also equal to 48. I know that the statements right here are still old, outdated, but ignore those for a minute. Just worry about the logic right now. So right now, oh yeah, sorry. See, this is a common mistake. I want to check equality, but this equal sign right here, the single equal sign, is an assignment, if you remember. If you want to check for equality, you have to use the double equal sign. See, almost 20 years of programming, and I still make this silly mistake. So, okay, write this code. And now, see, we have 3 independent if statements, and each one of them will run independently of the others. So if I actually put, no, not 45, sorry, I need to make this 48 in order for this to work, what I was trying to do here. So I'm going to actually close this, run again, and run again, and run again. So I'm going to actually type now 48. So as you can see now, if 48 is the value, then all of these 3 things will be true, and then true enough, they all come out, they all execute. In other words, if you put if statements like this, then you can actually run the conditions independently of each other. But if you're going to include else, then now the conditions will be now related. So now the difference between this and the previous if statement, now if you actually do this now, that means now you're going to check, you're going to actually get only one output in these scenarios. This is the first scenario, and if this is true, then the other 2 scenarios will be ignored. And if, let's say, this is false, right, then you come to the next one, and if this is true, this will also be ignored. And if the last one also is false, then obviously nothing is going to happen because they are all false at this point. Okay, so if you're not sure what, you don't have an exclusive condition in the end, you just want to sort of have a safety net to catch everything else, then this is how else is really used. So if you use an else if, that means the conditions are related, but if you don't put an else if, and then these conditions are independent of each other. So hopefully this is what I meant by independent conditions. Okay, so this is what I meant by multiple conditions. If you have multiple conditions and they are related, then you can use multiple if else statement, or actually else if, sorry, not an if else. Let me quickly correct that. So actually this is an else if statement. So if you actually have multiple scenarios, so now I hope by now when I actually go through these slides, I hope you understand the effect of the else command. So the idea is simple. If you have multiple if else statements like this, then now condition 1 and condition 2 are related, and this is actually what happens. You get what I mean? And if you want condition 1 and condition 2 to be independent of each other, then you can simply drop the else here, and then you check for both conditions. In fact, I want to do that right now. So I'm going to actually copy this whole slide and put it here, and then remove this altogether. And if that's the case, condition 1 will be independent of this true. So and then, yeah, this is now will work. And then only now, if you put an else, then they will check only for condition 2 only. So I'll check only if condition 2 is false. Yeah, only if condition 2 is false, because we have simply removed it from the equation. So hopefully now, um, you can see now the scenario here, right? So this is the scenario when you have an else statement, and this is the scenario when we don't have an else statement. So sorry, this is the scenario when we have an else, and then now this is the same scenario when we don't have an else. So these two conditions are actually independent of each other. Okay, so if you have multiple conditions in general, how you deal with it? Well, first of all, the way you deal with this is you can obviously use multiple else if statements like we did already, or you can combine logical and comparison operators, or you can use a switch statements. So how does that work? You see, the logical comparison, there is no right or wrong answer to which one of these techniques you want to use if you have multiple conditions. You'll have to think about your logic when you're developing the algorithm of this program or your program. You have to think about your logic and determine the relationship between these conditions. You have to ask yourself, are these conditions related to each other or independent of each other? Then based on that, you can determine the best course of action. You get what I mean? And then you can actually apply, sometimes you can actually apply the same technique in any of these cases. For example, if you want to use logical operators, all you really have to do is just check, you just simply use the operator. If you put condition 1 and condition 2 right here in the same statement, and then you can actually use the AND operator, then that straight away work will, this block of code will operate only if these both conditions are true. Which, if you think about it, will be, we didn't actually see the scenario before. What if you have two conditions? Actually, if both conditions are true, similar to this. So if this is true and this is true, then this will work. But then you'll have to write two separate statements. You know what I mean? So you F1 statement, F and then you'll have to repeat the code. But if you don't want that to happen, if you want to repeat the code in one shot, then you can actually simply use the AND operator. Now, if you want to check if either one is true, right, whether it's condition 1 or condition 2 are true, one of them is true, doesn't matter which one is true, then you can use then the else command. And I don't want to put an else here because that further complicates things. So let's just put it this way. So essentially, if you want to check for both conditions, and again, if you want to check for either conditions, and also if you want to check for the opposite of the condition. So this is again the not condition, the not operator. So if let's say you have a certain condition, sometimes you have a combination of things, like you have two conditions and stuff like that, and you want an opposite of that scenario, then you have, like for example, you have not and or nor actually. So just like you have not, yeah, just like you have an, you can actually, with this operator, you can actually create what is called the NAND operator, which is the not and operator. So essentially, it's the opposite of AND. You see, the AND operator is if both are true. But what if you want to check if both are false? Then you can actually simply take this and simply put an A outside. So that will become the opposite of it. And also you can do a NOR operator, which is the not or. In other words, once again, if either one of these conditions are true, well, what if you want either one of these conditions is false? So that's how you write or that's how you use the not operator. Let's do a little examples. Okay, so I want to check here, for example, if, and you can just simply say and angle is less than 45, if it's greater than 45 and it's less than 50. Okay, so in this case, you can simply write angle is between 45 and 50. Okay, so that's essentially how this is going to, this is the output is going to be out. And then don't want to put another condition, it's going to put it else. So else, so you're going to say that else, you can say angle is either greater than 50 or less than 45. So essentially, yeah. So if you wanted to actually, yeah, let's put an equal sign here and an equal sign here. And basically what you want, if the value is 45 or between 45 and 50, then this output is going to come, else we're going to get this output. It could be greater than 50 or less than that. So let's take a look. So compile, build, and execute. So let's pick a number that is less than 45, so 30. So obviously 30 will make this condition false because it's less than 45, so we're going to get angle is either. Is that right? So hit run, so angle is either greater than 50 or less than 45, which is true. By the way, these are actually two conditions also. So if you want to break this down into two separate conditions, you know the drill by now. You just put another if statement and then check out the conditions there. So again, let's just now, let's do that. So let's try this again and run. Let's just now put 48 again. So 48, so again, angle is between 50 and 50. You get me? 45 and 50. You got me? So this is actually then how you can, if you want to check, if you want to separate this into separate condition, then all you really have to do is check for the value is greater than 50, and then another condition, check for the value is less than 45, and then you can print out the equivalent, or excuse me, the specific statement. So I'll leave that exercise for you to do on your own time. What about all conditions? So let's just go back here and then change this to or. And or means either one of them. If it's actually, you know what, let's do this. So actually, I already wrote it down right here. If it's less than 45 or greater than 50, right? So if that's the true, then this statement should be out, right? So let's just come back here and put this, and in that, if it's not, then in this case, as you can see now, the way you implement logic, there are several ways of doing it. And in fact, we are just working with if statements so far. We haven't done yet the switch case. So I'm going to do that, then build it, and then execute it. And again, let's just now put a number that is less than 45 again. So if I put 30, once again, I'm going to get angle either greater than or 45, because now this is now is true. What's going on here is that essentially that angle is either less than 45 or greater than 50. So if I put a number that is greater than 50, so let's run this again and then run. So let's just say put 60, so then that condition is also true. This is false yet, but doesn't matter, but we care about this one only, so this one is true, so that's why this condition runs. So this is how the OR operator works. It checks two conditions, and if either one of these two conditions is true, then the whole thing will become true, and then result in this block of code running. And then the else, of course, is the opposite scenario. Does that make sense? Okay, well, that's now. So that was how you use if statement with conditionals. Now, one last thing to talk about is the switch case statement. Now, the switch case statement is used when you have several outputs, but you don't want to write a bunch of if statements. So as you can see it from here. And one of the greatest examples of using the switch case is when we work with the days of the week. And as you can see it right here. So this block of code, actually, the way that it works, this is actually copied from, again, from W3 schools. So I'm going to actually copy it directly. I'm going to put it in my code. So let's now go to our playground. I'm going to Control E all of this. And now I'm going to put the switch case. So this is now the how you write a switch case. So let's just take a look at the syntax here. First, we initiated a variable. This variable is called day. So this is just a declaration as usual. So this is declaration. And then the switch case actually works like this. First of all, you have essentially the block of code called switch. Think of it like the if statement. You have a block of code called switch. And then inside here, we are going to evaluate this condition. And in this case, the value is not true or false anymore. It's a specific condition. It has a certain value. And in this case, the day is going to be evaluated. So day is evaluated and is equal to 4. And now in this case, we're going to say that the switch is equal to 4. Okay? All right. All right, then what are you going to do with them? Well, we're going to basically do the following. We're going to actually check several cases. So this right here is the first case. Case number 1 is the case 1 right here. The value of 1 is actually how do you read this line right here? It simply means the case when the switch is equal to 1. That's exactly how you read this line right here. Okay, so how do you read this line is, well, what happens if it's the value of day is equal to 1. So once again, this is the switch, and this is the evaluation. After the end of this line, the value of the switch, we call it like that, the value of the switch is going to equal to 1, equal to whatever the value is. In this case, is equal to 4. Now, in this line of code, what's going on here is that we are saying that case 1 simply means the case when the switch is equal to 1, or when the switch simply equals to 1. If that's the true, then see out Monday. Okay? Now, I'm going to explain this in a minute, but just ignore it for now. Okay, so do we have other cases? Yes, we do. So I'm going to copy this whole thing. I'm going to put it here. And what about if the case is equal to 2? And if the case is equal to 2, obviously this will become Tuesday. You know what I mean? And essentially, this is how we're going to repeat until we get to the end of the week. So I'm going to copy the rest of the days, right? So copy, and I'm going to put them all here. So that's how all of the cases look. I'm going to do a little bit of organization a little bit. So I'm going to move things about. So just to organize the code a little bit. This is actually optional. You don't really have to do it, but just to make the code looks better. I prefer it this way. So again, here and here. So what's going on here is that basically you are going to check every case. Okay, so in case, now we're going to ask the same question, the case when the switch is equal to 1, if that's the case, and obviously this is not going to work. And then again, we repeat the same process here, right? So I'm going to copy this line, I'm going to put it here, I'm going to put it here, and then this will be 3. Obviously, that's not true. And then, whoops, now we are here. So the value is indeed equal to 4. Then what's going to happen? And then in this case, by the way, earlier when the value obviously does not equal to 4, so we're going to skip all of this. So just like an if statement, when the value is false, we're going to skip it. So again, in the case, when we are at this case, and this is not the value, then we're going to skip this block of code. When we come to case number 2, obviously that's not true because the value of day is equal to 4, or the value of the switch is equal to 4, so we're going to skip this part as well. We come here, we skip this part as well, and then when we arrive here, then we finally reach the truth. So essentially, at this case, let's just zoom in a little bit and see what happened. Because the value of the switch is indeed equal to 4, as we saw from here, then this code will execute. So what's going to happen here? Well, this is going to happen. C out is going to equal to Thursday. So if we are on the 4th day of the week, then that is actually C out. And then this line will execute. What is actually the break command is? The break command simply means if you actually reach this point, you do not have to execute the rest of the stuff. You just simply break this current block. Since we are inside the switch block, it's going to exit the block and it's going to come immediately here. So after you click on break, come here after hit the break. So if you hit the break already, if somebody pressed the break, or let's say you have executed the break, which is this line right here, then all of these will be skipped. And then you immediately come here, and then you simply outside of the block, and we're good to go. Okay, so that's essentially how this works. And again, I'm going to see out. I'm going to try to allow the user to actually set the day of the week. So I'm going to see out, and then here also I'm going to control E again. So enter an integer 1 to 7. Okay, so these are the 7 days of the week. And then C integer is going to simply put going to take this guy right here. I'm going to initiate it. I'm going to simply call simply just day without the value, and then we're going to put here day. So then this way the user can actually set the day, and based on that, different condition can happen at every different time. So if the user selects 1, we're going to get Monday, and then we're going to do true and then Tuesday. So let's just actually run it. So compile, build, and then run, and then now select a number. So if I hit 1, you should get Monday. That's good, and then exit. Now, what happens if I don't have any breaks? Actually, in this particular case, nothing is going to happen because once again, if the value is 1, it cannot be any other value, and we call that exclusive. But the problem with that is if you don't have these breaks, then the system is still going to perform all of these lines. So if I run this program right now and I execute, So if I put 1 again, you're going to get all of the days. Because what happened was is that even though that I executed this, then all of these commands were still going to run. And obviously that's not a good idea. So you want actually this to be, you want this to be um, exclusive. If you want this to be exclusive, then you have to hit the brake. So after you hit the brake, you will then exit the construct, and then you are already on the outside of the switch construct. So with this, I hope you guys have captured the switch construct. Then again, the switch expression is evaluated once, then the value expression is compared to the case. If there is a match, the corresponding code will execute. And then after that, we have the break keyword exits the construct once the match is found, and is done for efficiency. Since the cases are exclusive, there is no need to continue evaluation once the match is found. Now, the last thing to talk about, and this is only theory, and this is just a concept, is that sometimes when you actually sometimes you once again, we talked about this earlier when we talked about the try and accept scenario. Then you actually have a bunch of lines of code, and you worried about the output of this scenario. You might worry that this could cause a problem, could actually crash your program. For example, you ask the user to input a number, but then the user does not input a number, inputs a word, and then in that case, the program will crash. And this is the last thing you want to happen into your program. A program that crashes is definitely not good. And if you're a developer and you sell a product that crashes, then obviously you will be fired. If not alone, you will lose your business. So that's the last thing you want to do. But then again, on the other hand, you don't want the program to crash. And what you want to do is that then use the try and catch block. We're not going to code any of that. We're just going to introduce the concept to you. The way that the try and catch block, or the official name is exceptions, is that where you put the code that you were worried about here, and basically you want to try it. And then if the program if the program goes well and does not actually cause any error, in other words, you tell the user to input a number and the user does input a number, then we are all good to go. So this will run and this will essentially be ignored. But then if not, let's say if the user is a little bit cheeky and then they actually do not follow the rules and they input the wrong information and then causing the program to crash, the program, because you use the try and catch construct, the program will not crash. Instead, is going to catch that error, is going to catch that problem, and then it's going to actually capture it and inform the user. How does that work? Well, you can actually then write here a little bit of code. You can actually write a short message that explains the error and then perhaps include some instructions into what to do. For example, again, if the user typed a number, the user is required to type a number, but the user did not type a number, then you can write error warning. You are supposed to type a number and not a text, and then the user will follow the instructions, and then the program will run fine. Does that sound familiar? Did you see something like this before? And the answer is yes. Actually, if I just come and do this now and then just run this programming now, the program did not crash. Instead, I got an error message. This is exactly how the error message mechanism works. The way that the error mechanism works is actually through something very similar to try and catch. The way that the compiler really works is that it's going to try your block of code, but instead of just crashing out, it's going to check and try to see where the source of the error, and then it's going to tell you or send you a message that is going to tell you how the program, the cause or the possible source of the error. And this is how error messaging or error messages mechanism work, and this is how the try and catch mechanism works. Now, as a solid example of the exceptions or the try-catch statement in C++, let's take a look at a solid example. So this is actually a simple program that actually does a very simple job. So I'll just remove this math thing for now. And this is very similar to the Hello World program. All it does, and this is something we've done before. We initiate a variable, then we ask the user to input something, and then we assign that value to it. We've done this already in a previous video when we worked with capturing user input. And then we take that input and then we simply display it out again. That's all we're going to do. So let's go ahead and run this simple program. Success, and here we go. Enter a value. Okay, here's a value. And great, the value is right there. Okay, let's try this again. So enter, why is this indent? Oh, there's a space here. I think by mistake I put it there. So let's do this. Okay, so compile again, and then input, and then enter a value, anything, right? So I'm gonna put some gibberish text, and then it's gonna give me again nothing. That actually something else. Because I declared the variable as an integer, but when I typed text, so the system will not recognize that input. Okay, so this is essentially a general application. Now, let's just say now that you don't have this general input a value or enter a value. You want something more elaborate. So let's take a look at what is more elaborate mean. So let's just say that instead of input a value, you are required to enter something specific. Enter an integer that is within the predefined limit. And this is the predefined limit. In other words, that this number has to be less than or equal to 8. As you can see, this is a very strict requirement now. And why we need it that way, that's not the point. The point is that this is the requirement. So the requirement number one is we need an integer. And requirement number two, it has to be less than or equal to 8, right? So less than or equal to 8. So anything, any integer that is less than or equal to 8 will be accepted. But anything above that, so what are the possible failures? If the integer, let's say, is greater than 8, it will fail. Or if it's not an integer, let's say it's a float. Or if it's a text. So in any one of these conditions fail, then the input should not proceed to this step right here. So we actually introduced this before, and we called this issue validation, or we call this validation. We said in a previous video that you might want to validate the user input before you actually proceed with that input. And in this video, we are actually going, or actually in this section right now, we're actually going to do exactly that. So how does this work? So we want to do validation. So let's just actually now figure out the main construct of the validation program. So the validation actually looks like this. So let's just begin to dissect this one first. So first of all, it's going to be in a while loop. So let's just control X. So why is it going to be a while loop? Because what you're going to do is that you can actually take this prompt that you see here, which is, the one that you're actually going to capture from the user input. And you know what? Let's keep this one here, and then let's just drop this guy for now. And this is going to be our validation. So what I'm going to do, I'm going to take this prompt, I'm going to put it inside the while loop. Okay? And then what's the general strategy is that the general strategy is I'm going to actually ask the user to input the number according to this rule. And then basically, if the user follows instructions, right? Instructions, then exit the loop. Else, if not, let's say if that's not the situation, right, then if not the case, then inform the user. Sorry, first of all, reject the input, inform the user, or the user, right, and then restart, or reprompt. Prompt is this part right here when you actually tell the user to input something. What do you mean? How are you going to reprompt? Basically, you're going to come back to the loop again and going to start all over again. So once again, what is going to happen? So if the user input the follow the instruction, exit the loop. Now, if exit the loop, then what happens? If we exited the loop, that means we are done with the validation, and then we can now use the value. But let's say if the user does not follow the instructions, let's say does something against the rules, like here. So if the user does not follow the instructions, then in this case, reject the input. Reject means we cannot use it. And then inform the user, reject the input and inform the user. I'm going to make it one step right here, inform the user, and then reprompt. How do you reprompt? Basically, come back to the loop and then go back here and start again. This right here essentially is a shortcut. Essentially, this is a while true loop. And while true essentially is a loop that is going to run forever and ever and ever until you tell it to stop, essentially. And in fact, if I run this program right now, then you're going to see this prompt running forever, because that's exactly what the while true will do. In fact, let's go ahead and, for fun, let's go ahead and do this. So compile, success, and boom. And you can see that it's actually running, and it's going to keep on running until the end of days, or until I simply stop the program. So that's why this is the beginning, that we can actually simply ask the guy to tell us the value, and then we're going to check it. And then we can actually test the value. Now, the instructions are clear. It has to be an integer and it has to be within the limit. Okay, so what are the possibilities other than integer? So the first thing we have to conduct actually a few tests. So test number one, we'll have to check if the user inputted or entered, yeah, inputted, entered uh, a number, right? So it's possible that the user did not input a number at all. It could be a text, right? So could be a text or symbol or something like that. And that's the first test. Okay, could be essentially not a number, right? And then the next test after that, we want to test and check. Okay, maybe the user did input a number, but maybe that number is not an integer. So check if the user inputted or entered an integer or a float. You know what I mean? Or it could be a float, could be a double, or basically anything with a fraction, right? So essentially, it could be a float, could be a double, as long as it has a fraction or a decimal, right? And then after that, okay, let's say that that test was also successful. Then in this case, you want to check and see. Okay, so after the first test, we're gonna know for sure that it's definitely a number, okay, because we tested it. Because if it failed, we're gonna reject and prompt the user and start all over again. So if this test failed, we're not gonna come to these tests. It's just gonna immediately check this condition. If that condition failed, then everything else will be ignored, and we're gonna start all over again, and then gonna reprompt the user. So well, again, so how do we do that? We're gonna check that if let's say if okay, if not okay, then again this will happen, right? So we're gonna actually say gonna copy this, gonna put it here, reject and inform the user. Okay, then if this survived, or if this first test survived, then it's definitely a number. Then after that, we're gonna check whether that number was an integer or a double. So we're gonna check again if that's the case. If not okay means it's not an integer, it's a double, then again, we're going to reject and inform the user, right? And then finally, if it's an integer, but if the integer, there's one more test, by the way. Okay, at this point, it's an integer. Okay, that's great. So check if the integer, if the integer is within, or if, yeah, within the limits. This is the last test. So you see, right here is the final test. Okay, it could be an integer, okay, but it's maybe greater than 8, right? So it's still going to fail. So this is the last test. So again, if it's not okay, then reject and inform the user. And then after that, basically after that, if all of these three tests survived, then if all of these cases survived, then in this case, um, we are done. So in this case, you can say else. Then if that's the case, that means the user did actually follow the rules. So then in this case, exit the loop, and then we are good to go. We are happy. We can actually now use the value. Now, of course, we could have done this with if statement, but I'm going to use this example right here to use the try and catch block, because sometimes um, you could use an if statement to check a condition, but it's difficult to use an if statement to check an error. The best way to do this is to check using the try and catch block. So I'm going to come back here again, and I've already done this part of the code, so I'm going to actually copy. What we're going to do actually is this structure right here. So actually it's going to be, well, you know what, we can just do it here. So I'm going to simply say try, and then just do it, yeah, try, and then open the bracket, and then all of that is going to be tried here. So basically, all of our tests and experiments, right, was going to be inside this try block, okay? And if the try block worked, then if all of these tests survive, then basically, in this case, we're going to arrive at this line of the code, which means that the user, basically, if all of these tests succeed, so we're going to say success, the user followed the instructions, and then in this case, exit the loop. So that's basically how we're going to do this. Otherwise, if the user did not actually follow the instruction, then we're going to use a catch block. And this is how you actually write a catch block. Now, the way that the catch block actually, you must actually give it a number here. You must give it a variable, because sometimes you will have specific catches for specific errors. But if you want to do a general catch, then you just simply put the 3 dots like this, and that will be sufficient. So basically what's going to happen, if any of the tests above here failed, right, then in this case, this block of code will run. And what is this block of code will do is simply is going to say error, try again. So I'm going to take this prompt, I'm going to put it actually inside the try. Wait a minute. No, that is going to be actually that will remain here. So this prompt will always remain outside of the try block, but it's going to be in the while loop. So let's take a closer look of what's going on. So I'm going to close this try and catch block. So again, so this is now the structure of the validation code. We're going to basically put it all in a while loop. We're going to then give the instructions in the beginning, and then we're going to allow the user the chance to key in or to input the values. And then we're going to test the input that the user inputted. Now, if that value or if that input is successful, then we're going to succeed here and we're going to exit the whole thing. Meaning, if it's all good, then the try block will be executed and we're not even going to see the catch block. But if there's a problem in any of these three tests, then we're going to fail. And in this case, the try block is going to fail. And in this case, we're going to come and execute this part of the command. Is that right? So these are the three. This is now the general rule. Now, if let's say if we succeeded and this worked, then we're going to exit this while loop. And then we're going to come here and the value will be successful. Otherwise, it's going to be failed. And now, by the way, if we failed, by the way, let's just go back here. Let's just say the user did not follow the rule and we come here. Okay, we're going to inform the user, hey, user, you did not follow the rules. But after we finish this catch block, we are still inside the while loop. I mean, even after you finish this catch block, which is, inform the user that we have a problem, well, you are still within the while loop. So we're going to have to start all over again until the user follows and until the user arrives here. And by the way, this is very easy to exit the loop. We're just going to simply write break, which is exactly the same break that we saw earlier when we worked with switch case. If you remember, in the switch case, we had what is called the break. This is exactly the same command, a break. The break command is not unique to the switch statement. In fact, you can use it anywhere you want in the program to exit any block. You can use it to exit a function, you can use it to exit an if statement, you can use it to exit any kind of block if you want. And basically, it means simply exit this block of command and get up one level, something like that. So since we are inside a try block, or inside a try, since we are here inside a while loop, when you click on break, it's not going to exit just the try block, it's going to exit the whole while loop, and then it's going to exit. So, but once again, the way we exit the loop is simply by using the break command, which is right here. Okay, so right now, if I run the code, this will run only once because there is an exit, so the loop will only going to run just once. So let's go ahead and try it. Oh, we have an error input. I was not initialized in this function. Input was declared up here, so what's the big deal? Grade the value is. Did I use or forget a prompt? No. I declared the value. Oh, I did not change the value, or I did not update the value. Yeah, the value was declared, but it was not used. So, I'll just ignore that for a minute and let's just run it. Oh, wait, this is still the previous version of the program. This is still a warning, but the compilation is successful. The compiler is telling me that I declared the variable, but I never changed it. You know what I mean? So this input is going to come up with nothing. That's fine, and the value is 0, but because I'm not really doing anything yet. I'm just establishing how the break works. If I remove this command here, if I just comment it out for a minute, we're going to get back to that infinite program. You know what I mean? So this is basically to establish or to demonstrate how the block or how the break thing works. Okay, we broke it only once. Okay, so now what's going to happen? Now, basically, what's going to happen is that we're going to actually now going to use this. Now, okay, so what about the errors or the problems? So what's going to happen is that if this test fails, it's going to cause an error. And if it's going to cause an error, everything after it is going to be ignored. So even the break command is going to be ignored. So if this error happens here, we're straight away going to jump to the catch. That's what the purpose of try and catch. So once again, I'm going to say this. So let's say if we tried this line of code, it's a couple of lines of code, and they caused an error, right? Then if that error happens, the rest of the lines will be stopped, and straight away we're going to jump to the catch, and that result in the problem here. Okay, so let's do the first test. The first test actually, I've done this actually code before again, so I'm gonna actually copy this code from somewhere. Actually, I wrote it down here, but just gonna, because I don't want to write the whole code in one shot. So what I'm gonna do right now, oh yeah, before we get to that, so what I'm gonna do right now, I'm gonna actually come up here and change this slightly. I'm gonna call this guy input, integer, right? Because I want this to be an integer. And then I'm gonna actually declare a couple of more variable or more inputs. So I'm gonna call this guy raw, and this one I'm gonna call it as, you know, number, for number, yeah? And the raw one will be a string, and this one will be a float. If you want to call this double, also can, not a problem. But basically, what I'm gonna do actually, if you think about it, when you ask a user to input, there are only three possibilities really. It's either a string or a float or an integer. Nothing, right? You cannot type a Boolean, okay? If you want to type a Boolean, you just type 1 and 0, which is once again a number or a string, right? So it's going to be one of these three possibilities. So I'm going to actually declare or initiate three variables, a string for an input raw and an input num and input integer. And of course, this is what we want in the end. So at the end, I'm going to come down here, I'm going to type input integer. This is exactly what we want in the end. And this is still a warning because I haven't used the value. So we're going to ignore the warning for a minute. Okay, so what are you going to do after that? So what I'm going to do in the test one, how are you actually going to check whether how are you going to do this first test, which is how you're going to check whether the value is a string or a number. So in this case, what we're going to do, we're going to actually, first of all, I'm going to assume that the user typed a string. So essentially, by doing cn to input raw, basically I'm making an assumption that the user typed a string. So assume user typed a string. Even if, let's say, you typed a number, let's say 7 or 54.5, we're going to take that and we're going to put it as if it was a string. Don't worry, I'm going to convert later on. For now, this is what we're going to do. Next, after that, what we're going to do, we can actually use something called casting. And this is something I may have not discussed before in C++, but consider this is the first time we discuss it. So what I'm going to do right now, basically, I'm going to do this. I'm going to actually, first of all, I'm going to capture whatever the user input. I'm going to consider it as a string. So if the user inputted 5, John, or any kind of gibberish string, or symbols, or floats, or numbers, it's okay. I'm going to capture it as if it was a string. And then what I'm going to do is I'm going to actually convert it using, well, not convert it, this is called casting. And what I'm going to do is that I'm going to convert from a string to a float. This is what STOF stands for, string to float. And by the way, there is also STOI, which is an integer, but I'm going to do that. I'm not going to do that right now. I'm going to use STOF. And STOF or STOF simply means that take this value, whatever it is, and convert it into a float. So for example, if the user typed this, 44.5, right? Which is a string, by the way, then STOF is going to convert it into 433.44, which is essentially a number, which is basically a float. By the way, if you used STOI right here, then this guy, if the user typed this, then the value will be converted into an integer. It's going to ignore the decimals. But for now, we're going to work with the float version. So by the way, this is going to be the verb. Now, by the way, this STOF is a C++11 feature, I think. So it's available already without any extra libraries. Okay. All right. So well, then what? Well, after that, if it's all good, if it works, then this command. So, but before, what if the user typed this? Obviously, this is not a number. So obviously, this will not work. So this is now how you can capture the event when the user actually did not enter a number. So if the user actually typed something like this, obviously we cannot convert into a number, right? So that is why if user typed, or if the user did not input or enter a number, this will cause an error. This will cause an error. And that is, if you remember, this is the exact purpose of the try block. By the way, I'm not putting it inside the try block. Sorry, my apologies. So I'm going to actually do all of this here, actually. This is where you're supposed to be doing this. Remember, the purpose of the try block is to check if there is an error, right? Now, if I actually run this command and if the user typed a number, it will work. But if the user did not type a number, let's say type a text, then this will cause an error. But the program will not crash because once again, we are inside a try block. And instead, what's going to happen is that because this is an error, everything else after that, including the breakdown there, right, is not going to happen. It's going to be ignored. We're going to jump straight away to catch. And that will result in this block of command running. And then the value is going to tell you error, try again, and then after the catch ends and we're still in the loop, and then we're going to come back again to this prompt right here. So let's take a look and see how that looks like. So compile, see if it's successful or not. Yep, successful. And once again, it's giving me the same problem that input is not defined, input int. Warning, input int will be uninitialized in this function. Don't worry about it, it's just a warning. And build, okay, and then run this program. So input a number that is less than 8. So I'm going to begin by inputting a number. So 55.5. Great, the value, the value is 13. Okay, something is going on in the program. It's definitely not 13, so I'm not sure what happened here. So obviously it's supposed to capture the number. So st to float is a number. Oh yeah, because input int, the one that is actually here. So instead I'm going to do temporarily, I'm going to put number. Okay. So basically this is the variable that we have right here. Okay, so let's try to compile. Again, it's telling me that this variable was not used, which is input right here. It was not used. We can ignore it, but I can do this also. So compile. Okay, compile. And before we execute, let's once again take a look at the code. So once again, I'm asking the user to input an integer, and then I'm going to take this input, I'm going to put it as a string. Then I'm going to take the string and I'm going to convert it into a float. If the user typed a number, it will work. And in this case, the value of input number will be updated to the number that the user inputted. And then we're going to come here and print it out. That's what's going to happen. Now, if the user did not type a number, let's say text or something like that, then this will cause an error. And because we are inside a try block, then this actually is going to jump here to the catch part, and then it's going to tell me this message, and then we're going to try again here. So let's take a look. So compile, yeah, compile success, and then execute. So input an integer. I'm going to begin by typing 55.55 and grade the value as 55.5. And the program ends because you followed the instructions. Okay, let's try this again. So I'm going to write gibberish here, which is not a number. So obviously error, try again, but then we are still in the program. Enter an integer that is between the limits. So again, if I try another gibberish, it will still not work, and I can keep doing this forever and ever. It will not let me go until I type a number, and then finally the program responded. So this is the essence of validation. So as you can see here, we did a first step of validation only by using the try block, and we did not use an if state. But then again, this test right here only checks if the input was a number. We still have to check whether it's a float or an integer. Now there are several ways to, and this is basically the second test, which is right here. Now there are several ways to check whether the number is a float or an integer. The easiest of all is to check. Now let's see if I typed. Let's say if I typed a number, let's say 7, 4 or 4.0. Actually, these two are both integers. I know that there is a decimal here, but this is no fraction, no values. So these are actually, this is essentially a zero, a fraction. So therefore, this is an integer or a whole number. So that is how I'm going to actually test if the user inputted a fraction or an integer or not. So what I'm going to do, I'm going to wait for the user to type a number, and then I'm going to check this value right here, this fraction. And if this fraction is greater than 0, or at least it's not equal to 0, then obviously it's a float. So as you can see, this number right here is not equal to 0, right? So it's definitely not an integer, definitely a float. So that's exactly how I'm going to do it. So how do you actually do this? Well, I'm going to actually do a little bit of magic here. So basically what I'm going to check is I'm going to do what is called round down. Round down, or in some languages called floor, right? Essentially what it means is takes this number and is going to round it down to the nearest integer. So the result of this is going to equal to basically just 4.0, right? So then if I take this number, the original number, and I minus it from this number, I'm going to get only the decimal component by itself, like this. So that's essentially it. Now there are many other ways of finding the expression. You can use several other ways of finding the decimal section on its own. You can apply any technique you like, but I'm just going to use this one because I'm just happy with it. So what I'm going to do right now, I'm going to actually create a temporary variable right here, and I'm going to call it test. Simply going to call it test. And this is the input number. And if you remember, input number was the number that we captured from here. And if you recall, at this stage, we have confirmed that this is definitely a number, okay? Because if this actually failed, then we're going to exit all of this, and we're going to come straight away to the catch block. But if this worked, then we are now here. So what I'm going to do right now, I'm going to actually use input num minus floor input num. And floor is a advanced mathematical operation, so we need to include math. So include C math. So C math, and that will be all that we need to do. So that's essentially the program. So what is going on here? Basically, think of it like this way. So basically, if let's say if the number was 4 point something like that, so floor of this number is going to be essentially 4.0, right? So that's what the number is. So if I actually take these two numbers and I minus them from each other like this, from this guy right here, so the result is that I'm going to end up with just the decimal value. And this is basically what test is. Then this value right here, the 4 point something, or the fraction section by itself, is going to be allocated or assigned to the value of test. So this is basically the quick test that I'm doing here, or the quick calculation that I'm doing here, in order to just quickly calculate or find out the fraction. Then after that, I'm going to use a simple if statement to check if this value is actually equal to 0 or not, or at least if it's not equal to 0. So I'm going to actually take an if statement. So I'm going to essentially say if basically if this is the condition, bracket, and a bracket. So this is essentially how you write an if statement in C++. And then what I'm going to do then, this is the test. So if test is, if it's not equal to 0, how do you write not equal to 0? Well, actually, we did talk about operators before. So this is how you write not equal to 0.0. Now, because it's a float, I'm going to put a decimal here, so that's why it's a good idea. But if you forgot and you put a 0 like this, that will still work. So basically now, if it's not a decimal, obviously, sorry, if the value right here is not a 0, as you can see, something like this, so obviously the number is a float and not an integer. Is that right? And in this case, this is actually a failure. Now, what do you want right now? You want to have an error here. You want an error the same way we have it here. You could always do something like this if you want to cause an error, but there is actually a shortcut from C++. You could just simply do this, throw, and then we're going to throw a value. Just going to put simply, we're going to throw the value itself. It doesn't really matter what you throw, but you have to throw something. So I'm going to throw a test. So I'm going to put here and throw, that's it. Now, what is actually going on here? This line right here, it's simply what it says. This is essentially is a fake error. So what is going on here is that basically what's going on, what you're doing here, if this is true, meaning if the number that we have calculated is not 0, then the number is a float. Obviously, I don't want that. I want an integer. So if that's the case, throw an error. In other words, purposely cause an error. And when you throw something, you need to catch it. So where are you going to catch it? Right here again. So this is how the throw keyword actually works. And it usually comes along with the try and catch. Over here, we did not throw anything because we already have a situation where we're going to have a real error. Okay, me? But here we don't have an actual situation where we're going to cause any error. So I'm going to cause an error by simply throwing an error at the compiler. So when this actually line executes, that this is exactly the same effect as this line over here. In other words, that this is an error. And when this actually happens, once again, every line after that is going to be ignored, and we're going to come again back to here. So now we're ready. Let's test this second condition. So compile and then run again. So now remember, now we have two tests, if it's a string and if it's a float, and both conditions should fail. So this one we tried before, it fails. So if I actually put, now we come and put a decimal right here, and again that fails. And let's try, by the way, if I try with a 0 like this will work because this is considered a whole number. So again, if I try another integer or another float, anything you want really. Let's try a negative, by the way. So then, and then put a random number here, and then put a text to put a random number, and again it's going to fail. And this will only work if you put an integer or a whole number. So again, now this second test actually worked, which is check if the number is a float or an integer. Okay, so now we still have one more test. If you look at the code just now, I put an integer that is greater than 8, and that integer actually worked. We don't want it to happen. We want again to test if the value was within the limit. And this is the easiest of all. We just put a simple if statement just like this one, but then we check the value and then we move on. And now before we actually do that, so this is now the test number 3. Check if the value within the limit. Okay, so what we're going to do that? Well, first of all, at this point, you have to remember, if we have reached this point successfully, if we did not throw an error, in other words, if this was not true, then in this case, test value will equal to 0. Then if test value is equal to 0, that means we can arrive successfully or safely at this number. In other words, we will know that the user have indeed inputted an integer. So in this case, I'm going to come now and do this. Integer is going to equal to whatever number the user inputted. So I'm going to put it here, and let's recap what's going on. So first of all, the user inputted something, and so I'm going to capture that, and I'm going to put it as a string for now, because input raw was a string. Okay, let me activate this guy also. Okay, so then we're going to check if it's a number or not. If it's a failure, let's say if the user did input a text, then all of this is going to fail, and we're going to come to this catch block over here. Okay, now let's say the user did not input a string and it was text and inputted actually a number. So we're going to come here now and check if that number is a float or an integer. If it's actually a float, then we're going to purposely throw an error. Then we're going to crash the rest of the block, and we're going to come here again to this out, right? But then if it wasn't a float, and if indeed the user did type an integer, then we're going to basically confirm it. So we're going to now initiate input integer. We're going to set it equal to whatever the user inputted. Because if we arrived at this point, then we know for sure that the user did in fact input an integer. Now the only thing we have to check now is that if this value is within our limit, and that is the easiest of all. All we need to do is just another if statement. So I'm going to come here now. I'm going to do this. A little bit of organization. So now I'm going to check, and let's just throw this again. And basically, I'm going to check if the input value right here. Okay, copy. And if the input value, what is the condition? Actually, I already have the condition written for you right here. It has to be less than or equal to 8. So what's the opposite of that? Well, if the input wasn't less than or equal to 8, how do you fix it out? Well, the obvious answer is greater than 8, right? So if the input was greater than 8, then we can say now the integer is not within limit. What does that mean? Is essentially greater than 8. Now, of course, if you decided if you decided that right now the limit is hard coded right here, but if you want to make this limit user defined, then all you really have to change is to put the limit, the variable name right here. But then if it wasn't user defined and you hard coded right here, then just put the number this way. Okay, so less than or greater than 8, not 9. So greater than 8. So if they actually, if this is a, but obviously we don't want that. We want the integer to be less than or equal to 8. So obviously if it's greater than 8, so this will fail again. So how do you make something fail? Well, again, you throw another error. And then again, we throw another value, and then we're not going to throw test again. We're going to throw the value, this guy right here. It doesn't really matter what you throw as long as you throw something. If you cannot throw a blank like this. You cannot do that. I'm not sure if you can do this also, but then it's a good idea to simply throw something. I'm going to check it out after this. But anyway, so let's say that this actually worked. In fact, the user did input a number that is greater than 8. If that's the case, that is going to cause an error. Then this will fail, and we're going to come back here again, and the user will have to input. But let's say the user actually did input a number that is less than 8. And in other words, this did not work. And in this case, we can say that the test tree is also successful. And in this case, we finally arrived here, and then we can exit the loop. And exit the loop, basically, we actually finish this loop, and now we come back to the end of the program where we basically capture the value and then we display the output. Okay? So let's actually try this again, success, again, and execute. And now let's check out the situation. Text gibberish, fail. Float with numbers, fail. An integer greater than 8, fail. You can try whatever you want, it's not going to happen. Until you put an integer that is less than 8, and in this case, it will work. Great, the value is 5, and only then it will work. So this now is an example of validation, and also an example of using the try and catch block. And I hope this was a good demonstration of the try and catch block, as well as a good demonstration of the validation thing. Otherwise, well, with this now, we have now completed this part of the code, this part of the presentation. If we go back and recap the discussion for today, we talked about operators, we talked about operators, assignment, arithmetics, advanced math, and comparison and logical. And we also talked about if statement, as well as comparison with combination with logical and comparison operators, and the switch statement. And we also talked about exception. I know that the try-catch example may be a little bit advanced. It's okay. You don't really have to worry about it. You just have to watch and understand the concepts. If not, then it will be a good example for you to see how validation works. Otherwise, thank you very much. And this is it. In our next video, as we discussed earlier, we're going to focus on this part right here, on loops, functions, and libraries. And that will be the discussion for our next group of videos. So until then, thank you very much, guys. So I'll see you in the next video. Take care.